all the different kinematic pieces that go with an object in motion. We talk about velocity, initial velocity, final velocity, acceleration, the displacement of something, the time, how long it takes. So what I did was I put together a practice problem, and there's like 40 of them, and you don't have to do them all. And we're going to do the first 10. We are going to do together today. All right. And you can see I put the kinematic equations at the end of the practice problems. And then I said, when to use it. Whatever you're missing, this is what you can do to go find what equation you should be using. Okay, so the first problem says a car accelerates from rest to 20 meters per second in 5 seconds. Okay, what is the car's acceleration? So let's talk about this. So a car accelerates from rest to 20 meters per second in 5 seconds. Well, I would, considering it's going to show you how to do the problems. So remember what we talked about yesterday. What is the thing that's going to allow you to do these correctly every single time? Be consistent, right? Be consistent. Do the same thing every time. So this is not what I wanted. All right. So first things first. Not what I wanted. No, I want it to be, this is what happens when you let Mateo come in here and start screwing around with things. Whatever. Don't even care at this point.
I think you have to change that. You should.
No, because that's the same. All right, whatever. I don't care. I mean, I do, but I don't. Okay. So a car accelerates from rest to 20 meters per second in 5 seconds. What's the car's acceleration? So you're going to draw your chart. Yay. Okay. Your diagram first, right? Draw your diagram. Here we go. Here's my artistic ability. All on display. Okay. This is 0.0 meters per second. And then it's moving in the positive direction. And it finishes at 20 meters per second. Okay. This way is positive acceleration and displacement. This way would be negative acceleration, negative displacement. Negative acceleration, if it's going upward, it would be positive acceleration. Okay, so next thing to do is make your chart.
Going downward, it'd be negative what?
Negative acceleration going down. So initial velocity, final velocity, acceleration, time, and displacement. All right, so now you go back to your problem. What are you given? A car accelerates from rest to 20 meters per second. So what's your initial velocity? It's 0. It's starting from rest. So 0.0 meters per second. What's your final velocity?
20 meters.
20 meters per second. What's your acceleration? We don't know. That's what we have to solve for. Okay, so we're solving for that. And what's the time? Do we have the time? 5 seconds. Okay, do we have any displacement?
20 meters. No.
No, we do not. no displacement. Okay? So going to our kinematic equations. And what we see, what don't we have? We don't have displacement. So which equation are we going to use? Oh, look, it's the first one. When you're not given a displacement, you use this equation, VF equals VI plus AT. So it's VF equals VI plus A times T. Now you just substitute. 20.0 meters per second equals, what's your initial velocity? 0 plus A times T. T is 5 seconds. So condensed down, 20.0 meters per second equals 5 seconds A, if we're keeping the units in. How do we get A by itself? What do you do? By 5, right? 5 seconds? These cancel. Divide by 5 seconds. And this becomes 4 meters per second equals the acceleration, also known as 4 meters per second squared. Okay, so your acceleration for number 1, your acceleration is 4 meters per second squared. Okay, makes sense for a couple reasons. One, the units are correct. Acceleration will always be in meters per second. Okay, you don't have to find distance, but I will tell you down the road that you are going to have to solve and fill in the entire chart. We're not going to do it right now, but going forward, you're going to need to know how to do that. All right, questions about this one? Good? Okay. All right, so number 2, a bus slows down from 30 meters per second to a stop in 10 seconds. What is the acceleration? All right, so here we go. We have a bus. If you guys are jacking around behind my back, I will lose my mind. Do you hear me, gentlemen? Yeah. Okay, good. 30 meters per second is what it starts at. It's moving in a positive direction, so displacement's positive, but what's happening to the bus? So what way would acceleration be working? Backwards, against it. So acceleration is going to be negative for this, okay? And it comes to a stop, which means it's 0 meters per second, okay? All the people are still in here. Yay. Get me home. Okay. So your acceleration is negative going this way. Down, it would be negative here. If it's going up, acceleration would be positive, as would D. Displacement would also be negative. Well, not yet. Displacement would be negative down here if it was going underneath. Okay. So a bus slows down. So now you have your chart made, or you have your diagram made, which you need to do every time. Now you make your chart, which I will definitely have for you guys, so that way you don't have to waste time doing it. So initial velocity, final velocity, acceleration, time, and displacement. Okay. What's your initial velocity? What's it start at?
30 meters.
30 meters per second. What's it going to finish at? 0 meters per second. Acceleration, we don't know. That's what we have to solve for. Okay, and what's the time? 10 seconds. Displacement, nope, don't have it. Doesn't matter, we don't need it. All right, so as you go through, say it again. It was in the problem. So again, what don't you have? What are you not given? You don't have acceleration and you don't have displacement. So you're solving for acceleration. And when you're not given displacement, what equation are you going to use? It's the same one. So, and which will happen. So VF equals VI plus A times T. Again, now you just sub. Final velocity is 0 meters per second equals initial velocity, which is 30 meters per second, plus what's your acceleration? That's what you're solving for, and 10 seconds. So it's 10 seconds A. Okay? Yes, that's right. All right, so what do we have to solve for? We have to solve for acceleration, right? So this is what we need to isolate. We need to isolate the A, so what do we have to do first? We have to subtract 30 meters per second for both sides. So negative 30 meters per second equals 10 seconds A. Okay? How do we isolate the A? Divide by 10 seconds. These cancel. You're left with acceleration equals negative 3 meters per second, or negative 3 meters per second squared. Either answer is correct. Okay? Hold on. Why does this answer make sense? Right, it's slowing down, so the acceleration is going to be negative because it's working, even though the bus is moving in a positive direction, it's slowing down. Well, how do things slow down? They have a negative acceleration. It's deceleration. Was that your question, Ava?
No, I was going to ask, in the first problem, we multiplied A by 5. Why didn't we do that for this one? We did.
We did 10.
Just
Oh.
do the step.
Oh, sorry, I didn't see that.
That's all right.
Why is it squared?
Acceleration will always, because when you figure, that's why I do it with the units to start,
Yeah.
because you see that it becomes, when you divide this, it's meters per second, and then this divisional sign is still there. It rates to the units. So that's why it becomes meters per second squared, or meters per second. Okay, either way. Doesn't matter. You can do it either way. And acceleration will always be meters per second squared, or meters per second.
Okay.
Velocity will always just be either kilometers per hour or meters per minute. There will be no square in the unit.
Okay.
All right? Good question. All right. So let's go back. So let's do number 3. Number 3 says a skateboarder increases speed from 5 meters per second to 15 meters per second over a period of 4 seconds. Right out of the chute, what do you know that acceleration has to be? Negative or positive?
Positive.
Has to be positive. It increases. Velocity increases. So because the velocity is increasing, it's going to be a positive acceleration. All right, so you have a skateboarder increasing speed. Okay, he's probably coming down a ramp. All right, this ought to be interesting. Said no one ever. Okay, so he starts at 5 meters per second. Okay, but it's going downward and it's going to accelerate to, this one will be much better. Not. To 15 meters per second. Okay, so looking at it this way, acceleration's positive, displacement would be positive, coming down. Probably not a good way to do this, but acceleration would be negative. But in this case, because it's speeding up, it's going to be that. What is your acceleration? So let's make our chart. VI, VF, A, T, D. Okay. So initial velocity, 5 meters per second. Final velocity, 15 meters per second. Acceleration, what we have to solve for. Time, 4 seconds in the problem. Distance, don't have it, or displacement. So what equation are we going to use? Same one. VF equals VI plus A times T. What's your final velocity? It's 15 meters per second. Your initial velocity is 5 meters per second, and your time is 4. Okay. So let's combine this first. Make all the steps. 15 meters per second equals 5 meters per second plus 4 second A. Okay. How do we get A by itself? We have to subtract 5 meters per second from both sides. And you come up with 10 meters per second equals, this cancels, 4 seconds A. How do we get A by itself? Divide by 4 seconds. And A will equal 2.5 meters per second or 2.5 meters per second squared. Questions? Makes sense, right?
Yeah.
So far, so good?
Yeah.
JD, you feel better? Okay. Colton, you feel better? Okay, good. All right.
Wait, can you guys have one more second?
Do whatever you'd like. I'm also recording it, so I'll be posting it in Google Classroom.
What do you mean? Like
I'm recording a screen record, so that way you can see it. What?
On the chart, no.
Diagram or chart?
The diagram.
Okay.
Would we have to put like the A plus in the arrow? Like, do we have to do that?
You should, just to keep it, to have the label so you know what you should be going with. Yes. All right. Okay. Are you guys good? Are we good? You're welcome. All right. So I want to go into a different one. All right. Let's do number 11. A car traveling at 15 meters per second accelerates at 2 meters per second squared for 10 seconds. How far does it travel? Okay. So a car's traveling.
I say A negative.
Yeah, sorry. So it starts at 15 meters per second. Okay, it's moving this way and it's accelerating for 10 seconds. So it comes to here. We don't know what the final velocity is. Okay, we don't know what the final velocity is. And we know that the acceleration is 2 meters per second squared. So let's make this chart. So VI, VF, acceleration, time, and displacement. So initial velocity, 15 meters per second, good. Final velocity, we don't know. Acceleration is 2 meters per second squared. What's your time? Good, 10 seconds. And your displacement. That's what you have to solve for. Okay? So that's what you're solving for.
Wait, I have a question. How do we know which one we're solving for?
It doesn't say it in the problem.
A car traveling at 15 meters per second accelerates at 2 meters per second squared for 10 seconds. How far does it travel?
Oh, okay.
So far being the key word. All right, so what do you need? You need to solve for displacement, but you don't have final velocity. All right, so let's look at our kinematics. All right, right, so it's going to be the second one. Displacement, D equals VI T plus times A times T squared. All right, so we're solving for, and we have all those variables, right? We have VI, we have T, we have acceleration, we have T, so we're good. All right, so D equals initial velocity of 15 meters per second times time, which is 10 seconds, plus 1/2 of 2 meters per second squared times 10 squared. All right. So you just need to distribute, or not distribute, you need to just combine your terms, okay? 15 times 10 is 150 meters plus, well, what's 1/2 of 2? 1, right? So you have 1 meter times 100, and it's going to be 100 meters. So what is the displacement? The displacement is 250 meters. So there's two ways you can write this as a correct answer. You can say D is positive 250 meters, because that would be understood that it's going to the right, or the displacement is 250 meters to the right. Either one of those answers would be correct. Questions? Okay. So I'm going to skip around now.
Did we get one where we solve for time?
Yes, we can do that. All right. So number 16. A cyclist accelerates from rest at 2 meters per second squared and travels 60 meters. How long does it take? All right, so you have a cyclist. Oh, God. Awesome. All right, so a cyclist accelerates from rest. So it's 0 meters per second and travels 60 meters. So the distance or the displacement is D equals a positive 60, okay? Your acceleration will also be positive because you're going that way, okay? How long does it take for the cyclist to travel 60 meters accelerating at 2 meters per second squared? All right, so VI, VF, A, T, D. Okay, what's your initial velocity? Starts from rest. What's your final velocity? Do we know it? No, we don't. Okay, so we're just going to put a little X down there for now. What's the acceleration? 2 meters per second squared. Do we have time? No, that's what we need to solve for. And what's our displacement?
60 meters.
Plus 60 meters. All right, so we don't have final velocity, and we need to solve for time. All right, so You are not given final velocity, so what do you need to solve for? Time. So which one are you going to use?
The second one.
You're going to use the second one.
Yeah.
So it's D equals VIT plus 1/2 of A T squared. So your displacement is what? 60, right? Plus 60?
Yeah.
60 meters equals, what's your initial velocity?
0.
0. So it doesn't even matter what the time is. This cancels. So 0t, that gets canceled. And you're left with 1/2 of 2 meters per second squared times t squared. So what do we have here? What is 1/2 of 2? So you're left with what?
60.
60 equals what? What is this? So that becomes 1. What's 1 times t squared? Is that our answer?
Yeah.
No. How could that be our answer? It can't be our answer, okay? So what you're going to be left with is you have meters squared over seconds squared. No, meters over seconds. Sorry. No. Meters over seconds squared. Sorry. All right. So how do you get t by itself? It's squared. You have to take square root. Okay. So t would be whatever the square root of 60 is. Exactly. Square root of 60 equals 7.75 seconds. That's how long it would take for it to travel 60 meters in a positive direction starting from rest. But now I want to know, how fast are they going when they get to the 60 meter mark? So what does that mean we have to solve for? Final velocity. So in that case, if we're going to solve for final velocity, we can use whatever one we want because we have everything. So I could use this one, but why? I'm dealing with squares. Can I use this one? VF equals VI plus AT? Absolutely. So to solve for final velocity, I'm going to do VI or VF equals VI plus A times T. But you already know that this is 0, and you know that acceleration times time gives you speed, okay, or final velocity. So final velocity equals 2 meters per second squared times 7.75 seconds. Okay, the seconds cancel with that, and you're left with, it's like 15.50?
Yeah, it's 15.5.
So your final velocity is 15.5 meters per second. Questions? Does it make sense?
Yeah.
Does anybody, seriously, I need to know, does anybody have questions? Ask them. God bless. Evan, you good? Sort of, until you start doing them.
Sure. Yeah.
So here's the thing, what I want you guys to do, so I did the first 3 for you guys, so you already have them, which those of you that didn't do it while I was doing it, that was dumb, so now you have to go back and redo them. What I want you to do is I want you to do 4, 5, 6, and 7. Just do 4 more, okay? Do them now. I am only grading on your attempt. I'm not grading on accuracy or anything else like that. Because what I'll do is I'll make up the answer key and post it for you guys as we go through all of these problems. All right? 4, 5, 6, and 7. I would just do them. I would do 1, 2. I would do 4, 5, 6, and 7 right after them and just take a picture and turn it in. Yeah. All you have to do is just take a picture of it and post it in Google Classroom. Anthony, why are you grabbing at what I guess is your own Chromebook on Jonah's desk?
I just,
What did it do? Jump off of your desk to his desk? It flew? Magic.
it fell in a weird way.
That's good. Well, at least it fell on the desk.
Such a weird thing. Here.